We're super close here. The next two are pretty straightforward. This one's super easy. This question is asking us what volume will 1.18 moles of O2 occupy at STP. This is just a really important relationship between moles and volume of gases only, when they're at standard temperature and pressure conditions, or when they're at 0 degrees Celsius in 1 atmosphere. You simply have to remember that 1 mole of any gas at STP is equal to 22.4 liters of that gas. So as we look at this question, we have a little bit more than 1 mole, so we should have a little bit more than 22.4 liters. We're going to bust it into some dimensional analysis here. So 1.18 moles of O2 times moles of O2, liters of O2. 1 mole is equal to 22.4 liters. So using our amazing mathematical skills, we should get 26.4 liters of O2 at STP. So again, just an important relationship here between moles and volume of gases at STP. 1 mole, 22.4 liters. Done. And our final problem of the day, well, what happens when we're not at STP? As you look at number 11, how many moles of a gas at 104 degrees Celsius would occupy a volume of 6.8 liters at a pressure of 270 millimeters mercury? Now, before you start these problems, again, think back to the good old days of first year chem. Anytime we're working with problems involving gases and gas laws, really important to make sure that your temperatures are in Kelvin, and you can convert from Celsius to Kelvin by simply adding 273. So when we add 273 to 104, we get 377 Kelvin. I'm also going to convert my pressure from millimeters mercury to atmospheres, and this is important because of the gas constant I'm going to use. You can do this a couple different ways, but I always like to use atmospheres, and I just memorize the gas constant in terms of atmospheres instead of trying to memorize a bunch of different gas constants. But you do what you want, I'll do what I want. And the conversion between millimeters mercury and atmospheres is 1 to 760. This is on your formula chart if you ever forget that. Which means that 270 atmospheres is the same as 0.355. Sorry, 270 millimeters mercury is the same as 0.355 atmospheres. Okay, all this work and we haven't even started. We're looking for the number of moles of a gas at 104 degrees Celsius or 377 Kelvin that would occupy a volume of 6.8 liters at a pressure of 270 millimeters mercury or 0.355 atmospheres. To solve this, we're going to use PIV-NERT, PV equals nRT. Really very important. And for our first unit, we're really just going to be using it to solve for volumes and numbers of moles. Molar mass and densities and things like that we'll take a look at later, much later in the year. Then it's just a matter of plug and chug. Our pressure is 0.355 atmospheres in a volume of 6.8 liters. Our number of moles are IDK. That's what we're looking for. Our gas constant is 0.0821, and our temperature is 377 Kelvin. Now, I should have included the units for the gas constant, but note that all these other units are going to cancel out except for moles when we solve this. So I'm going to sort of drop units here and then just use moles at the end because I'm a cheater. So we're going to multiply these two together, and we're going to get 2.414 on the left-hand side equals x times 30.9517. Divide each side by 30.9517. Boom. X is therefore equal to 0.078 moles. And again, I know I was a terrible teacher and dropped all the units there. I'm just lazy. Don't forget to include your units at the end. And that concludes our guided practice problems for today.